Let's look at calculating the pH of a weak base. In this example, I've chosen to use the benzoate ion, anion. And the benzoate anion is the conjugate base of benzoic acid, right here. Now, in order to do this problem and determine the pH of a weak base, we will need to know what the Kb value is for this reaction. However, a lot of times when you look up values for Ks in tables, the Kb's will be missing and they'll only have Kas. And you might say, what do I do? Well, fortunately, there's a formula that will convert Ka to Kb, and it is Ka times Kb equals Kw. So I'm going to write that right down here so we have space to still put our ice table up here when we get to that part. So if we look up in our table, we'll get Ka, but this is not the Ka reaction. This is Kb. But again, fortunately, Ka times Kb equals Kw. And so when I look up in the table and I see that Ka for benzoic acid is 6.25 times 10 to the minus 5, then I can move the Kb over, or Ka over to here. Well, we'll get to that in a minute. So I've got 6.25 times 10 to the minus 5 times Kb equals Kw, which is 1 times 10 to the minus 14. So I'm going to divide both sides by 6.25 times 10 to the minus 5, and that will give me Kb. So Kb equals, and in this case, it's 1.6 times 10 to the minus 10. Which is a very small K. It's much smaller than our Ka. And really all that means is that benzoic acid is a better acid than its conjugate base is a base. And this holds true for most of the carboxylic acids. The opposite is true for the nitrogen-based bases. They're generally a better base than they are acids. All right, so now that we have our Kb, we just need to make up a concentration that we'll use for this species right here, the benzoate ion. And I've chosen 0.2 molar for this. So if we had a solution that's 0.2 molar of the benzoate ion, and we don't have any of this in the solution or that, and these are aqueous right here. This is a liquid, that's the solvent, this is aqueous, and the hydroxide's aqueous as well. That may come in handy when we're writing our equilibrium constant expression. So again, we're using our ice table. Initially we have 0.2 molar of this, none of those. We're going to say minus x here. We're going to make x of these. 0 plus x is x. Now we'll need to plug this into our Kb expression, and we're using Kb because this is a base reacting with water, so this is the Kb reaction. And that will just mean benzoic acid times the hydroxide concentration divided by the benzoate concentration. So we should have x times x divided by 0.2 minus x. So let's write that out. X times x is just x squared. divided by then 0.2 minus x. And this equals our KB, which is 1.6 times 10 to the minus 10. Now, again, this would be a quadratic, but let's see if very much of this will actually ionize in solution or react. We have a very small k. This is 10 to the minus 10. It is many orders of magnitude smaller than our 0.2. So, very little of this reaction is going to go forward. Therefore, our x is going to be very tiny compared to our 0.2 concentration. So we can just ignore this minus x and simplify our problem. So in that case, we just take 0.2, multiply it by both sides to get it over here, and then take the square root of that, and we should get x is equal to 5.66 times 10 to the minus 6. Now, before we get too ahead of ourselves, I always like to look back at the reaction and see what x was calculating. And in this case, the relevant thing to look for is the hydroxide ion. In our previous example, where we were calculating for a weak acid, x would have been H+. But since this is a base, it's hydroxide ion. So we cannot just immediately take negative log of this to get the pH. We instead need to use our 14 plus log of the hydroxide ion concentration to get the pH. So I'm going to do that. 14 plus log 5.66 6, and this should equal 8.75. And again, I generally like to write 2 decimal places because that's how accurate pH probes are. So this is an example of how to calculate the pH of a weak base that's just been put in solution. We have to use an ice table, and we need to make sure that we're using KB. It is possible that you'll be given a Ka even if there is a base in the solution. So you need to be able to identify what bases look like and what the acid form of those things look like. And I had a video on that, so if you're a little shaky on that, go review that or ask more questions.